All right, so good evening and welcome. My name is Erica Zarzan, and I'm the Public Awareness Coordinator for the Alzheimer's Society of Saskatchewan. And it is my pleasure to welcome you to our Healthy Brains presentation presented by Dr. Cindy Barha. Our topic tonight is on the benefits of exercise and cognition and brain health, specifically looking at how to use exercise more effectively as medicine and how biological sex and genetics are moderators of exercise efficiency. We will end discussing ways everyone can incorporate exercise into their daily lives. Before we get started, I just want to remind you that the presentation is being recorded, but only the presenters will be shown on video, not the participants' videos or names. You can turn on the closed captioning feature during this presentation by clicking the option at the top of your screen or in the toolbar at the bottom right. And during the presentation, you can type your questions in the Q&A function at the bottom of your screen, and we will have a question period at the end of the presentation. We do ask that you please keep your questions relevant to the presentation, and if you have any follow-up questions, please do not hesitate to reach out to our society staff, or you can email myself or call our Dementia Helpline at 1-877-949-4141. I will now offer a land acknowledgement from a provincial perspective. The people of the Alzheimer's Society of Saskatchewan are privileged to live and work across the traditionally sacred land we now know as Saskatchewan. We recognize the enduring presence of the Cree, Dakota, Dene, Nakota, Lakota, Saulteaux, and Métis people, who are the original stewards of the rolling hills, rushing rivers, and living sky we all share today. As an organization, we acknowledge the harms of the past and how Indigenous people are still impacted by the process of colonization. Through partnerships, education, and collective action, we commit to honoring our relationship to the land, our treaties, and each other as we journey towards Wokotehisiwin. I now want to introduce our featured speaker tonight, Dr. Cindy Barha. She is an assistant professor in her second year in the Faculty of Kinesiology at the University of Calgary and a Canada Research Chair, Tier 2 in the Neuroscience, Brain Health, and Exercise. She completed her PhD in Behavioural Neuroscience at the University of British Columbia, followed by the postdoctoral training in the Department of Physical Therapy at the University of British Columbia that was funded by a fellowship from the Alzheimer's Society and Brain Canada. She has published over 58 peer-reviewed papers, and her translational research aims to promote healthy brain aging by determining who benefits from exercise by focusing on biological sex and genetics, when in the lifespan to most effectively intervene with exercise, and how exercise exerts its influence on the brain. And in her free time, Cindy enjoys hiking and exploring Calgary playgrounds with her 2- and 4-year-old boys. Welcome, Cindy.
Well, thank you so much for that lovely introduction. And I'm so happy to be here tonight. And thanks everyone for joining us, especially with the time change, which apparently Saskatchewan doesn't partake in. So it's just me that suffers. So today I'm going to talk about, share some of information with you about how exercise can improve brain health, as well as how we're attempting to increase the sort of the utility and efficacy of exercise as medicine for the brain by taking more of a personalized medicine approach. So that's still research that's in its infancy, but I'm pretty excited about some of the stuff that we found. So I'm sure we're all aware dementia is a global health issue. Worldwide, 1 new case of dementia is diagnosed every 3 seconds. And 1 in 3 seniors actually dies with Alzheimer's disease or another dementia, killing more than breast cancer and prostate cancer combined. So a report from 2015, which is now almost 9 years old, indicated that by the year 2050, over 131 million people will suffer from dementia. And actually, newer projections published 2 years ago are even more dire, suggesting that the number will actually triple from 57 million in 2019 to 153 million in 2050. And the situation is very similar here in Canada. So according to the landmark study, which is a modeling study done to predict dementia prevalence in Canada between 2020 and 2050, it's actually projected that 6.3 million Canadians will develop dementia, with an average of 685 individuals being diagnosed every single day. So the annual cost to the Canadian economy and our healthcare system will be over $10 billion. And you can see that in Saskatchewan, there will be a 142% increase in the number of people living with dementia. And here in Alberta, where I am right now, we're projected to have the largest percentage increase in dementia compared with the other provinces. So this is most likely due to the higher growth rate and faster aging population compared to the other provinces. So if we can delay the onset of dementia by even as little as 1 year, this would result in 500,000 fewer cases by 2015. And if we could delay by 10 years, this would result in 4 million fewer cases. So to me, this really suggests that prevention is a primary concern. And females really do seem to be at the center of this disease. So 2/3 of all people with Alzheimer's are female. And females also have a greater lifetime risk of developing Alzheimer's disease, which is partly related to their longer lifespan of about 4.5 years. But there's more to it than just that. So even data from that landmark study that was done here in Canada does show the same sex difference, with about 60 to about 63% of people living with dementia in the year 2022 being females. And so that's the yellow bars, yellow parts of the bars in the provinces up here. And that same study projects that this trend will still be seen 30 years from now in Canada. And in fact, the percentage of people living with dementia that are female will actually maybe even increase a little bit, they predicted. So females also show greater cognitive decline after they've been diagnosed. And in both human and in rodent models, females show greater Alzheimer's disease neuropathology within the brain. And so this includes those hallmark pathologies that we do see in Alzheimer's disease brains. So females will have more tau tangles and more of that amyloid beta plaques. They also show greater and faster atrophy of the hippocampus. So that's a part of the brain that's really, really important for creating and recalling memories. It's also that first part of the brain that shows shrinkage in Alzheimer's disease, and females show more of this. Some non-modifiable risk factors for dementia also show a sex difference and have a greater impact in one sex. So, for example, the ApoE4 gene variant has a stronger effect in females than it does in males. So many of you may have recently heard about ApoE4 in the news. So everyone carries this gene. It's called the ApoE gene, but it comes in different variants or different forms. So the E3 variant is neutral, and most of us carry that form. The E2 variant is less common, and it's actually associated with protection against dementia. And then there's this ApoE4 variant, and it's one of the greatest genetic risk factors for developing Alzheimer's. So last year, the great actor Chris Hemsworth, aka Thor, told the world that he actually carries 2 copies of the ApoE4 gene variant, one from each of his parents. So he's actually 4 times more likely to develop Alzheimer's disease as he gets older than another man that carries the E3 variant. But to me, what's really interesting is that if Thor was a female, he would actually, or she would actually be 12 times more likely to develop Alzheimer's disease. So carrying 1 copy is related to 2 times greater risk in males and 8 times greater risk in females. So to me, there really is a clear sex difference in this genetic risk factor. Other risk factors are specific to actually one sex. So for example, oophorectomy or surgical menopause and even natural menopause are sex-specific risk factors for dementia that are found in females. And I'm going to talk a little bit more about this third one that I've listed here, pregnancy history, in a little while. But there is some suggestion that even pregnancy history could be a sex-specific risk factor in females. So I want to understand what sets up the female brain for Alzheimer's disease and for cognitive decline. And I want to determine how we can promote the health of our brains through exercise as an intervention in both males and in females. So a really quick note about the vocabulary that I'm using today. So I've been speaking about sex differences. So sex refers to a set of biological attributes in both humans and in animals. It's primarily associated with physical and physiological features, including things like your chromosomes, your genetics, hormone levels, and reproductive anatomy. Gender, on the other hand, refers to the socially constructed roles, behaviors, expressions, and identities of girls, women, boys, men, and gender diverse people. So gender influences how people perceive themselves and how they perceive each other and how they act, interact, as well as the distribution of power and resources within our society. So today I will be talking about sex differences because the variable that I'm looking at is sex assigned at birth. But I do want to acknowledge that we really can't disentangle the influence of gender in most of these cases, including in my own research that I'll touch upon today. So most likely it's really both sex and gender that are playing a role here. Okay, so in addition to non-modifiable risk factors, which account for about 60% of dementia cases worldwide, 12 modifiable risk factors have been identified that account for about 40% of cases. So these factors include things like smoking and alcohol use, head injury, and diabetes. So elimination or reduction in any of these risk factors will have a substantial impact on dementia cases and dementia prevalence. So developing interventions that actually target these modifiable risk factors, I think is really, really important. And like I mentioned earlier, while some risk factors are unique to one sex, so for example, menopause in females, other risk factors may be prevalent in both sexes, but still may have a stronger impact in one sex. And so importantly for my own work, physical inactivity is one of these modifiable risk factors that may actually show a sex difference and may be more important in one sex. So some not so recent work now in 2021 out of Finland actually suggested that physical inactivity was a significant risk factor for dementia in females, but maybe not so much in males. So in this table from the study, I'll walk you through that. You can see that in females, which I've marked down here in red, physical activity was significantly associated with reduced risk of dementia, as shown by what we call a hazards ratio, which is in here is equal to 0.61. So if that hazards ratio number was less than 1, then that would mean a decreased risk. If the hazard ratio number is actually significantly bigger than 1, that would be an increased risk. So since this number, 0.61, is bolded in black, this indicates that the relationship between physical activity and dementia risk reduction was significant in our females. On the other hand, in our males, which are in blue here, the association between physical activity and risk of dementia was actually not statistically significant. Even though that hazards ratio number is 1.1, it's actually not significant. So there was no relationship between physical activity and dementia risk in men. And so this data supports this idea that physical inactivity is a stronger risk factor among females, and that maybe increasing physical activity levels may be more important for dementia risk in females compared to males. So what actually is the evidence for physical activity and exercise for promoting cognition and the health of our brains? So, well, overall, there is actually quite a large body of evidence that shows that regular physical exercise has really great promise in both the prevention and maybe even the treatment of cognitive impairment. So in 2016, the Global Council on Brain Health, which is just an independent group of scientists, health professionals, and policy experts that are international, released one of the first evidence-based consensus statements that actually supported physical activity and exercise in the maintenance of the brain health. So they provided several different recommendations, including the need for moving more throughout the day. So reduce your sedentary behavior, get up and walk around more. And they also recommended making concrete plans to move your body. So actually scheduling exercise sessions. They also recommended doing more than 2.5 hours of aerobic exercise, as well as at least 2 bouts of strength training. And their fourth recommendation down here, I think is really kind of interesting. They recommended do more of what you love to do or try something new with other people. So I think this is a great recommendation because you know socialization is really important for brain health. So doing some sort of new physical activity with a group of people may actually be even more beneficial for your brain. For individuals that are living with mild cognitive impairment, or MCI, the American Academy of Neurology actually included exercise for the first time in their practice guidelines in 2018. So they recommended that clinicians actually tell patients that have been diagnosed with mild cognitive impairment to start to include regular exercise as a part of their management plan. And more recently, physical activity and exercise were also included in the World Health Organization's guidelines as evidence-based strategy for reducing both dementia risk and cognitive decline. And so these different expert recommendations, as well as others that are like them, are all based on evidence that's gathered from research studies that have been done looking at physical activity and exercise. And so physical activity and exercise studies are usually either things called cohort studies or they're randomized controlled trials. So the two types of studies are sort of best viewed as being on a continuum of evidence, from weaker evidence all the way to stronger evidence. And so cohort studies are on the weaker part of the evidence continuum, whereas randomized controlled trials are on the stronger part of the continuum. So cohort studies are descriptive in nature, and they allow for us to sort of look at associations or even correlations between physical activity levels and cognition. So cognition is your thinking and memory abilities. On the other hand, randomized control trials allow us to look at more of a cause and effect relationship. And so they provide stronger level of evidence. So cohort studies are population-based studies that recruit participants from the community, and they don't have any sort of prescribed treatment or intervention. Instead, they measure physical activity levels in their participants using things like self-reported questionnaires, or in some rare cases, they objectively measure physical activity using things like accelerometers that are kind of like Fitbits or Apple Watches, just much better. So in cohort studies, measurement of physical activity, as well as the brain health outcome that's being looked at, so for example, cognition, your thinking and memory abilities, these are usually measured at baseline, so when the participants first enter the study. And then they're also measured again at different time points longitudinally. So randomized control trials, on the other hand, they actually manipulate the amount of exercise by randomizing participants to either an exercise group or to a control group. And usually in exercise trials, the control groups either get no exercise or less exercise or a slightly different type of exercise. So in this type of study, in the randomized control trial, the brain health outcome, so cognition in our case, is measured at baseline. Then the participants are randomized completely by chance into either the exercise group or the control group. And then that outcome is measured once again after the exercise or control program is complete. Okay, so before we go on, I just want to make sure everyone is aware of the difference between physical activity and exercise, because I have been using both of those terms. So physical activity is any bodily movement that increases energy expenditure above a resting level. So it's like an umbrella term that basically encompasses physical activity that's related to things like household activities, occupational activities, transportation, and leisure time activities. In general, physical activity can be either unstructured or it can be structured. And if it's structured, then we refer to that as exercise. So what is exercise? So it's a subset of physical activity which is planned, structured, and repetitive, and has the goal of improving our cardiovascular fitness. So broadly speaking, there are just typically two distinct forms of exercise. There's aerobic training, so that's like walking, running, and jogging, and it's aimed at improving cardiovascular health. And then there's resistance training, so lifting weights, that's aimed at improving muscle strength. So each of these types of exercise modes or forms has its own distinct physiological benefits as well as their own benefits for the brain. You can also combine the two types of exercise, and this is considered multimodal exercise or multimodal training. Okay, so the third source of evidence for physical activity and exercise benefits for our brain that we're going to look at today is called systematic reviews and meta-analyses. So these are the sort of the gold standard for evidence in clinical science. So a systematic review basically attempts to gather all the available research studies that are done by using a really clearly defined systematic methodological approach to obtain answers to a very specific question. So for example, we could look at all the randomized control trials that have been done to examine the effect of aerobic exercise on memory in older adults. A meta-analysis, so you may have heard that term before, it's the statistical process of analyzing and combining all the results from all those different studies in order to give one single summary number that tells us the strength of the effect or the amount of a relationship between the things that we're looking at. And this is called the effect size. So when you're thinking about levels of evidence, cohort studies are at the weak end, randomized control trials are at the stronger end. Meta-analyses of cohort studies give us a bit stronger evidence because they're combining the results of several different studies. And then meta-analyses of randomized control trials give us the strongest evidence, and they really are the gold standard. That's what we really want to see, is meta-analyses of randomized control trials of exercise. Okay, so a little bit more background here. So I'm going to go over how to understand a typical graph that usually presents meta-analyses results. And I hope this is helpful for today and also like for other science talks as well. So like I said, meta-analysis is a statistical technique to combine the findings of lots of different studies that are looking at a similar thing. So RCT is looking at aerobic exercise interventions on memory. They assess the effectiveness of the intervention by providing an estimate of the treatment effect, which we call an effect size. So usually meta-analyses present their results in graphs that look something like this. So the effect size is usually represented by a symbol, like a diamond like this. And the red line here is the line of no effect. So if there was no effect of the intervention and the control group was equal to the exercise group, then that diamond would fall along that line of no effect. If the effect favored the exercise group, so the exercise group's memory performance was better than the control group in our example, then the diamond would fall on this side of the graph. On the other hand, if the effect favored the control group for some reason, then the diamond would be on this other side of the graph. And so the further over on one side that diamond is, the bigger the effect is. Okay, so now that we have all these definitions, hopefully they're in your mind still and they make sense and that I explained them right. We're going to look at a few examples of how cohort population studies have in general shown us that higher physical activity levels are associated with lower risk of dementia, as well as better cognitive health in older age. So here's a somewhat famous meta-analysis that combined the results of 9 cohort studies that were all looking at the association between high levels of physical activity and dementia risk in adults that are older than 65. So in those 9 cohort studies, physical activity was assessed using a questionnaire at baseline, so when the participants first enrolled in the study, and then dementia risk was assessed years later. And they found in their meta-analysis that overall the effect was statistically significant with higher levels of physical activity associated with a smaller risk of dementia over time. And you can see that down here, because that black diamond, it's pretty small down here, I've circled it in green, that black diamond is on the side of the red line that denotes decreased risk. If it was the opposite, then that diamond would be on the increased risk. But luckily for us, physical activity is associated with reduced dementia risk, so it's on this side. Okay, so that all those studies in that meta-analysis were cohort studies that looked at self-reported physical activity. So they used questionnaires and they asked their participants how much they exercised or how much activity they did. So that's not always reliable, nor is it very sensitive. It's better to objectively measure physical activity. So there is one really great large cohort study in the United States that's quite famous because they follow community dwelling people for many years into older age. They also asked the participants to donate their brains to the study after death. So this is called the Rush Memory and Aging Project. And it's actually still going on. So they're still doing assessments. They're still enrolling participants. And in the study, participants undergo cognitive testing, so thinking and memory tests every year for many years. They also do a lot of other assessments, so physical functioning assessments, sleep assessments, lots of different things. In 716 of those participants, in later life, the researchers actually measured total daily exercise and physical activity using a wrist-worn actigraphy unit. So that measures movement. They're kind of like an Apple Watch, but they're way better and they're much more sensitive. So the 716 participants wore those units, so those wrist watches, for 10 days each year for an average of 4 years. And of the 716 people, 71 of them did eventually develop dementia. So this right here on this slide, this is what the actigraphy output would look like for one participant over the 10 days that they wore the watch. So each line is 1 day. And you can see that there's quite a lot of variation in movement counts day to day. So each black line is a movement count. Right here, you can probably notice it's very little movement every single day. And that's because this person is sleeping between 12 midnight and 6 a.m. But what I want you to notice is there's a lot of variation in how much movement this person is doing each day. Okay, so those researchers, they found that overall higher late life physical activity as measured by that watch was associated with better overall cognition. So better thinking and memory abilities, and also less decline over time. So the higher the level of physical activity, the less decline that they showed. Unfortunately, I don't have a graph for that. They also found that those with high levels of physical activity, so that's the shown by the red line here, those people showed reduced risk of dementia, and fewer of those people developed dementia as the study went on. In the people that had low physical activity, so that's the black line here, they had greater risk of dementia, and more of them developed dementia as the study went on. So of those 716 participants that had been wearing the watches every year, 428 of them have died by the year 2017 when the analyses that I'm going to present now were done. And they had donated their brains to the study. So the age of death ranged in these participants between 66 and 108 years of age. So the researchers have looked at lots of different measures of brain pathology, so looking at what's happening in the brain. So I'm going to present findings for just two of those markers. So we're going to look at the relationship between late life physical activity levels and brain cell loss or neuronal death, as well as the number of brain lesions. So higher late life physical activity was associated with less neuronal death, so less brain cell death, and also associated with fewer brain lesions. So in this graph here, you can see that the group that had no lesions had higher daily activity counts, which is on the y-axis here, so the vertical line, versus those that did have lesions in their brains. The group that showed little to no neuronal death, so they showed very little cell death in the brain, they had higher daily physical activity counts compared to the group that did show lots of neuronal death in their brains. Okay, so overall, the cohort data does support this idea that physical activity is good for brain function and also good for dementia risk reduction. But with cohort studies, we can't actually say it's a causative effect. So for example, we can't say that low physical activity levels caused the increased risk of dementia. It could be that higher dementia risk leads to lower physical activity levels, and that's called reverse causation. So this now famous study looked back at 28 years of follow-up data in a cohort study of people to see if they could find evidence for this reverse causation. And that's exactly what they did. They found that physical activity levels in people living with dementia actually began to decline up to 9 years before a diagnosis was made. And so you can see that here in this graph. So the y-axis, the vertical, is the amount of moderate to vigorous physical activity that the participants engaged in. And the x-axis, so that's the line that's on the bottom there, that's the number of years before diagnosis with dementia was made. The blue line here is the dementia-free cases. And you can see there's very little change in the amount of physical activity that they did over that 20-year period. In the dementia cases, which is the red line, you can see there's a big drop actually in physical activity levels around 9 years before they were diagnosed with dementia. Right around here, you can start seeing that quite rapid decline. So to better address this whole cause and effect issue, we really do need to look at randomized controlled trials of exercise, where we are actually manipulating and controlling the amount of exercise that our participants are doing. But as I said before, what we really want is evidence from meta-analyses of randomized controlled trials of exercise. So we want to be able to combine a bunch of exercise trials and put them together to come up with one single effect size. So engaging in exercise interventions does seem to be beneficial for cognitive function in older adults. And you can see this in the seminal meta-analysis that was done by Stanley Comey and Art Kramer, which in a way sort of set this whole field of exercise and brain health in motion. So exercise, which is in the white bars in this graph, is associated with benefits to several different cognitive domains versus control groups, which are in the gray. And in this particular meta-analysis, exercise had its greatest beneficial effects for the domain of executive functions, which are higher order cognitive processes that really in a way enable and drive adaptive and goal-oriented behaviors. You may never have heard of this term, so we're going to go a little bit more into it. So these are a set of mental processes that allow us to plan, focus our attention, remember instructions, and juggle multiple tasks successfully. So the brain needs this set of skills to filter distractions, prioritize tasks, set and achieve goals, and to even control our impulses. So So in research, we say there are three main executive functions, and those are working memory, inhibitory control, and set shifting. So they're very important for everyday functioning. You're actually using your executive functions right now as you're sitting here in front of your computer, I think trying to pay attention to what I'm saying while keeping track of what time is dinner, is also simultaneously trying to inhibit your natural tendency, which is probably to check your email or your phone. And so there are many ways in the lab that we can actually measure executive functions. One really popular way is to measure the executive function of inhibitory control using a task that's called the Stroop task. And so we're going to try that right now because I think these terms don't really mean much until you try it. Okay, so I've never done this on Zoom, so I hope it works, and I hope everyone at home is trying this. So I want everyone as fast as you can to read out loud the words in this column, starting with red, green. So continue on, read them out loud. Okay, now as fast as you can, say out loud the color of the ink that the X's are written in. Start with blue and go down. Okay, now as fast as you can, say out loud the color of the ink that the words are written in. So not what the word says, but the ink that they're written in. So the first one would be green. So do this as fast as you can. Okay, so I hope everyone tried that. I hope that you all could see that that was a lot harder to do. You have to inhibit your natural tendency to read the word and instead say the color of the ink. That uses your executive functions. Okay, so using tasks like that Stroop test, this meta-analysis of randomized control trials done in older adults found that exercise had its greatest beneficial effect on tests that tapped these cognitive processes and these skills that are under that umbrella term of executive functions. But despite these, promising results, there actually is a lot of variation still found in exercise efficacy for cognition, as not all studies find these beneficial effects. So one of the best examples is the LIFE trial. So this is one of the largest and longest exercise randomized control trials that's ever been conducted with over 1,600 older cognitively healthy people. And they actually found that a 2-year multimodal exercise intervention didn't increase performance on several different tasks, including memory tasks, or even on those executive function tasks, including that Stroop test. And this was in comparison to a health education control group. That 2-year intervention also didn't alter the incidence of dementia. So right now, a major goal of the field of exercise neuroscience and brain health is to enable precise evidence-based exercise recommendations for brain health by better understanding the sources of this variation that we are seeing in these different studies. So we want to understand why some RCTs, some randomized control trials of exercise, aren't finding these really positive beneficial effects for cognition. So to do this, we can examine the what, the who, the how, and the when of exercise. So what type of exercise is best? Aerobic versus resistance training, or maybe a combination of the two, or even considering other alternative forms of exercise like yoga, tai chi, and dance. And for whom each of these different types of exercise is most effective in promoting cognition. So that includes looking at sex differences, looking at your genetics, even considering cognitive status, such as looking at individuals that are at a higher risk for dementia. We can also look at how these different types of exercises are exerting their influence on the brain. And we'll talk a little bit about neurotrophic factors as one of the hows later on. And finally, we can also examine when exercise is most effective at improving brain health by taking more of what we call a lifespan approach. So for example, comparing midlife versus older age in terms of exercise. So the rest of my talk today, I'm going to speak about some of our own work examining the who and the how by asking, do sex differences exist in effective exercise on cognition? But I do want to mention that we and others are actively examining when in the lifespan to best intervene with exercise for males and whether this is different for females. So we decided to focus on sex differences to see if we could help everyone understand the variation that we do see in exercise study effects. So we decided to do this because of the fact that we already knew there are strong sex differences in cognitive aging and in dementia risk and prevalence. And we also wanted to look at sex differences because there does seem to be a sex difference with physical inactivity as a risk factor, and it might be more important in females. So I talked about both of those earlier on. So we wanted to do a meta-analysis of randomized control trials to compare the beneficial effect of exercise on cognition, so on our thinking and memory abilities in older males, and compare that with older females. But at the time, there were actually almost no studies that had been done with only females, and actually no studies of exercise had looked at sex differences. And this wasn't actually surprising to me. So we've known for a long time that science studies don't really examine sex differences in outcomes, even when the study is looking at something like a drug treatment for Alzheimer's disease, which is a disease with a very strong sex bias. So these are findings from a paper that my PhD supervisor, Dr. Lisa Glia, published in 2022, and they caused quite a bit of stir. So they looked at all of the studies that had been published in the fields of neuroscience and psychiatry in 2009 and also in 2019. And then they compared the percentage of studies that used both sexes, so males and females. And you can see that the percentage did go up from 38% to 68%. So I guess that's good. But then they found that very few of those studies in either year were actually looking at sex differences. Only 2% in 2009 and 5% in 2019. So that's not good. They have the ability because they have both sexes in the studies, but they're just not looking at sex differences. I also want to take a second to point out one more thing from this paper, because I think it's something that's really important, and I kind of will touch upon it later. So it's these stats down here. So 27% of the studies were done in only males in 2009. And 27% of studies were only done in males in 2018. But only 3 to 4% of studies were ever done in females only. And so to me and to others, this really points to the fact that women's health, female health research is undervalued, understudied, and underfunded. So that is something I'm very passionate about. So I'm always happy to talk about female brain health. And we can do that in the Q&A if you would like. Okay, so back to exercise, the reason we're actually here. So in order to start to look at potential sex differences in exercise effects on cognition, I still did a meta-analysis. So we identified 39 randomized controlled trials that were done in older, cognitively unimpaired adults. But what we did was we split the studies into those that had a high percentage of female participants and those that had a lower percentage of female participants. So then we could compare the effect size, so that strength of the relationship between exercise and cognition in the studies with lots of females, and compare that to studies that had less females, so more males. And when we looked at aerobic training, so that's running, walking, jogging, and its effect on executive functions, so that's what we need for that Stroop test, we found that overall, the effect benefited the aerobic training group. That's that black diamond here compared to controls. So that black diamond's on the right side of the line of no effect. So it shows that there was a benefit of exercise. And we found that the effect of aerobic training on executive functions was actually greater in the studies that had more female participants. So that's the purple diamond compared to studies that had fewer females, so more males, which is the blue diamond. For resistance training, so that's the studies that use strength training, we found that overall, the effect benefited the resistance training group compared to controls. So that's that black diamond here. It's on the right side of the line of no effect. And we found, similar to what we found with aerobic training, there was a greater effect of resistance training in studies that had more female participants compared to studies that had fewer female participants. And the same thing for multimodal training studies. So studies that used resistance training and aerobic training in some sort of combination. There was a greater beneficial effect on executive functions in studies that had more females. So it does seem that the females might be benefiting more from these different exercise interventions. So we also have another meta-analysis that looked at aerobic training studies with cognitively healthy older rodents, so older mice and older rats. And we found that in studies that let the rodents run as much or as little as they wanted to, using running wheels in their cages, the beneficial effect of running, of aerobic training, was the same in female-only studies compared to male-only studies. So aerobic training running on this wheel was good for their cognition, regardless of whether they're male or female. But in studies where the rodents were put on a treadmill and they had to run a certain amount at a certain intensity, which is a lot more like what we do with our human studies, we found that the beneficial effect of running, of aerobic training on memory was much bigger in female studies than male studies. So that's that purple diamond. So then we wanted to look at why or how aerobic training could be influencing the brain differently in males and females. So I looked at the effect of aerobic training on something called brain-derived neurotrophic factor, or BDNF for short, in that rodent meta-analysis. So what is BDNF? So this is a neurotrophic factor. It's a substance in our brains that's involved in neuroplasticity and neuronal health. So we need it to keep our brains healthy. You can think of it as a super vitamin for the brain. And previous work in rodents and some in humans had already sort of suggested that exercise was increasing levels of this BDNF in our brains. So as expected, when we looked at this, we found that overall the effect size benefited the exercise group. So that's that black diamond here. So that running, that aerobic training was increasing BDNF levels compared to controls. So that's good. And actually the greatest effect of aerobic training on BDNF levels in these studies was in females only compared to male-only studies. So to me, this really suggests that this BDNF, this super vitamin, may be one possible reason that we're seeing this sex difference in exercise effects on cognition. Okay, so since at the time there was no randomized control trials that had directly looked at sex differences in exercise effects on cognition, we decided to do it ourselves. So we used data from a completed randomized control trial that was done by Dr. Teresa Lou-Ambrose at the University of British Columbia, where I was a postdoc. So this was a 6-month randomized control trial with older adults with vascular cognitive impairment, which is the second most common form of dementia after Alzheimer's. So half the participants received a 3 times per week moderate pace walking program, and the other half were in the control group, and they received usual care and education materials. So the main findings of the paper showed that aerobic training improved episodic memory and reduced blood pressure compared to controls. And this was in both males and females. For my sex differences, I actually looked at executive functions. So looking at tasks like that Stroop task. So this graph here is showing change in performance on a test that measures executive function, similar to that Stroop test. But this time here, negative change scores actually indicate an improvement in performance from baseline. So the negative is actually good in this case. And we see that in females, aerobic training in the dark purple improves executive functioning on this test compared to controls, which are in the light purple. In our males, the aerobic training actually didn't improve executive functions at all. And if anything, it actually, aerobic training seemed to reduce executive functions. So at this point, I usually just leave the story that females show greater cognitive gains from exercise. But, I'm sorry, guys, sorry, men, you aren't off the hook. Of course, you need to exercise still. So for example, although we didn't see in males that benefit to executive functions, what we did see was these really nice improvements in cardiovascular fitness. And we didn't see these improvements in our females. So this is kind of interesting because we've always thought that the aerobic training improves brain function through increases in fitness levels, but that doesn't seem to be the case in our females. So what could it be? Well, we turned once again to our super brain vitamin, BDNF, and we found that at trial completion, aerobic training increased levels of BDNF more in females than in males. I've also been able to look at this potential sex difference in exercise effects using data from a 10-year cohort study called the Health, Aging, and Body Composition, or Health ABC study. So this is a study with about 2,900 older adults that were recruited from Memphis and Pittsburgh in the United States. At intake, so at the start of the study, they were between 70 and 79 years of age. So these are all well-functioning, community-dwelling adults that were cognitively unimpaired at baseline. So the researchers assessed physical activity levels through self-reported time spent walking, and they measured this every year from years 1 to 10 of the study using a standard questionnaire. And so we were able to look at individual trajectories of change in the amount of time they spent walking over that 10 years. So we had some participants who increased their amount of walking, some that decreased their walking, and some that maintained the amount of walking over the 10 years. But on average in this cohort, time spent walking actually decreased by about 8.4% each year. So executive functions were assessed in a similar test that was used that we looked at before, the Stroop test. And they gave this test years 1, 3, and 5, and 9. So every couple of years they did this test. So once again, we're able to look at trajectories of change in performance. So we had some people that maintained their performance over time, some that declined a little bit, and some that declined quite a bit over time. They also looked at global cognition. So this is overall thinking and memory abilities using a test called the Modified Mini Mental State Exam, or the 3MS. So this is a test that's given orally to people to look at overall cognitive function. It's also used as a screen for dementia. And they gave this test several times over the 10 years as well. So the main findings for that paper, we found that in only females, higher baseline time spent walking, so higher levels of physical activity, was associated with less decline in executive functioning. Maintaining or even increasing the time they spent walking over that 10 years was actually associated with less declines in executive functioning as well. In both males and in females, we found that maintenance or increasing the amount of time they spent walking was associated with less declines in their global overall cognitive function. So in a small subset of these participants, we actually got pictures of their brains using an MRI at year 10, so at the end of the study. And we used that data to look at the relationship between the time spent walking over that 10 years and the volume of the structure in the brain that we need for executive function. So the part of the brain that we need for that Stroop test. And that part's called the prefrontal cortex. And we looked at this in males and females. We only found a significant relationship in females. So more time spent walking was associated with a larger volume of that brain structure, only in females. There was no association in males. So very quickly here, we found converging evidence that from 3 different types of studies that suggest there is a sex difference in aerobic exercise effects for executive functions, so for the Stroop test, with females showing greater benefits. And this could be related to aerobic training having a greater benefit for the structure of the brain that's required for executive functions, or it could be related to aerobic training increasing levels of that super brain vitamin, more so in females. So we've found these really interesting sex differences favoring females. And now we want to try to understand why are we seeing these effects. So one idea that we had was that in females, maybe the effectiveness of physical activity and exercise could be dependent on reproductive experience or reproductive history. And we thought this because there's emerging evidence that shows that previous parity, so the number of previous pregnancies, can actually alter a female's risk for dementia in later life. Okay, so we know pregnancy has profound effects on female physiology and brain function, as well as disease risk in both the short and the long term. So don't worry, I'm not going to go into this figure very much. I just want to briefly show that during pregnancy, there are really large changes across lots of different systems, as well as decreases in total brain volume and memory function. In the short term, so within a few years of giving birth, in the brain, there are reductions in the volume of some specific brain regions, as well as we see improvements in certain thinking abilities. But it's important to note that some of these changes that we're seeing are dependent on the number of previous pregnancies. So for example, first-time pregnancies versus second and third-time pregnancies have different effects on thinking ability, at least in rodents. And we know much less about the effects of previous parity in middle and older age. So one of the areas that we know even less about is how it affects the brain. So some studies do find that risk for Alzheimer's disease seems to increase with high parity, 5 or more pregnancies associated with increased risk, as well as nulliparity, having 0 pregnancies has been associated with greater risk. I think I'm running out of time. Nope, maybe not. Okay. Okay, so we wanted to see whether previous parity alters the relationship between physical activity and cognitive aging. So we used data once again from the Health ABC study. And as I showed before, these researchers looked at global cognitive function and executive function. And physical activity was looked at through self-reported questionnaires. We broke down total parity into 4 different groups. So females that had 0 complete pregnancies, those are the nulliparous females. And we had a low parity group, so women that had 1 to 2 complete pregnancies. We had a medium parity group, so females that had 3 to 4 complete pregnancies. And then we had this grand multi-parity group. So these are females that had 5 or more complete pregnancies. We found that higher physical activity was significantly associated with better overall cognition, so overall thinking and memory abilities, but only in the nulliparous females, so females that had 0 complete pregnancies, and in the grand multiparous females, so females that had 5 or more complete pregnancies. In the low and medium parity groups, there was no significant association between physical activity levels and global cognition. And we see the same thing with executive functions. The nulliparous group and the grand multiparous group showed better executive functioning with higher levels of physical activity and no association in the low and medium parity groups. So it seems that the greatest benefits of physical activity may be seen in the female groups that are most at risk for cognitive decline and dementia. Specifically, we saw a strong association between physical activity and cognition in females with the highest amount of parity, which is possibly the group that's most at risk for Alzheimer's disease, as been previously shown. As well, we saw a strong association between physical activity and cognition in the nulliparous females, so the 0 complete pregnancy group. And nulliparous women may also be at greater risk for dementia. And we've shown in nulliparous rats that in older age, it's this group that has impaired memory function. So I'll talk about maybe this in the Q&A if people want to talk about resistance training, because I didn't really talk about it, but we know resistance training is really important for brain health. And actually, it might be more feasible than aerobic training in older adults with mobility issue. There's not as many studies done with resistance training, but we have shown that it is really important for brain health. So the last minute here. So I think importantly, you don't need to be out there training to run a marathon or trying to look like Dwayne "The Rock" Johnson. Even as little as 10 minutes a day of brisk walking in older age is beneficial for the brain. And you can get really creative with how you incorporate exercise into your daily life. So for example, you could start taking the stairs instead of the escalator or elevator. You could start gardening or mowing the lawn. Probably my least favorite suggestion, you could start vacuuming the carpets in your house more often. And because winter is still here, at least in Alberta, you could start shoveling your driveway. It's a great form of exercise. You could offer to babysit your grandchildren, your nephews, your nieces more, take them out to the park, run around with them, play tag. So these types of activities may not seem like they're exercise because they don't involve you going to the gym or going to a fitness facility, but they are exercise. And together, they actually increase your level of physical activity quite a bit, and they will help your brain in many of the ways that we talked about today. And so while we may not be at the stage of being able to sort of prescribe exercise as medicine in order to best protect your brain health and say sort of which form of exercise and at what intensity and volume each particular individual needs in order to promote their brain health based on things like their biological sex, their genetics, and possibly other factors like reproductive history. We do know that being physically active is good for your body. And I've listed, there's some different effects right here. And we also know that exercise is good for your brain. Okay. So I'd like to thank everyone that's helped along the way, my mentors at UBC and here at the University of Calgary. And I've put my email up there in case anyone has questions that I don't get to today.
Wonderful. Thank you so much, Cindy. I really enjoyed your presentation, and I hope everyone did as well. It was really interesting learning more about how we can care about our brain through physical activity and how physical activity actually affects people differently. So thank you so much. So we will soon be getting to the questions in the Q&A. I know we are getting short on time, so I hope everyone sticks around and I invite you to put your questions in now. And while you're entering those, I will just briefly tell you about the Alzheimer's Society. So the vision of the Alzheimer's Society is to live in a world without Alzheimer's disease and other dementias. And the mission is to empower people to live well with dementia through the delivery of programs, services, advocacy, awareness, and research. There are multiple Alzheimer's Society resource centers across Saskatchewan. In fact, in the 2023-24 fiscal year, we served 2,700 individuals from 300 communities across Saskatchewan. And I just do want to note that you do not need a formal diagnosis to connect with us, and we do support those affected by Alzheimer's disease and other dementias. So we have resources and knowledge about many types of dementias, such as vascular dementia, which Cindy mentioned in this presentation. And what you can expect from the Alzheimer's Society of Saskatchewan is individual information and support available for both people living with dementia and their care partners. We also offer learning opportunities. So we have our learning series courses to help people with dementia and their families and friends to live as well as possible with the disease. And of course, we have our evenings of education, such as this one, which are standalone topics presented by content experts. And we also offer connections. This is through our support groups, which give people a chance to exchange information with others living with and affected by dementia, access the most current information, learn and share practical tips for coping with change, decrease feelings of loneliness and isolation, and express feelings and be reassured that these feelings are normal, and of course, find a sense of hope. We also offer our Minds in Motion program, which I hope interests some more of you after tonight's presentation. This is a 2-hour weekly program that combines physical activity and social activity for those with early stage dementia and a friend, family member, or care partner. We also provide connections to other organizations. So this includes providing information on available services provided by the Saskatchewan Health Authority, other government agencies, and lists of private or community-based organizations that help support people's dementia journey. So if you have any questions about dementia or need someone to talk to, you can call our province-wide Dementia Helpline phone number, which is listed on the screen, Monday to Friday, 8:30 a.m. to 4:30 p.m. And lastly, before we get to the questions, I just want to make a note about donations. As a nonprofit, 3 out of every $4 that the Alzheimer's Society of Saskatchewan receives comes from donations. And these donations really inspire hope to provide early diagnosis and greater awareness efforts for new medications and treatments, to provide strategies for coping, to provide care partners the confidence in their abilities, and to continue serving Saskatchewan communities with support and resources that reflect their needs. So thank you. I will now get to some questions for our presenter. Perfect. Okay, so can you explain BDNF a little bit more and where that comes from? And can people take that as a vitamin that can be purchased?
Oh, I wish. I really wish. And that's my mistake using it, saying it was a super vitamin. No, we can't actually buy it yet. Though there are people out there trying to sort of like research groups that are trying to isolate it enough and create it in the lab so they can monetize it. I don't think it's going to really happen because when you eat a pill, the stomach and everything, like it'll probably never make it across the blood-brain barrier. So that was my mistake by calling it a vitamin. Where it comes from, it's mainly made in the brain. So it's made by neurons, it's made by other brain cells called astrocytes. We don't really know where it comes from in terms of exercise. So there is some studies that find that it could actually be made in the periphery, so not just in the brain, made in muscles. And then from the muscles, it could be taken in through the blood and through up to the brain and stuff like that. So we're not really sure where BDNF is made in terms of exercise effects, but the main source of BDNF is your brain, and it's going to be made in the brain and presumably stay in the brain.
Okay. Would you have info on the benefits that yoga provides to the brain, especially for women?
So yoga is a really interesting exercise intervention. So there have been studies that have done yoga as the primary intervention, and some of them find slight increases in cognitive function from yoga itself. We actually incorporate bits of yoga into our control program. So our control program is a balance and tone program, and it has things like balance exercises and yoga exercises in it. And so what we actually find is that the control program itself does end up helping cognitive function a little bit. And so we do make our lives a little bit harder because our control program does help brain a little bit. And then we're comparing our aerobic training, resistance training to that. So we haven't looked at yoga specifically by itself, but there has been studies out there, and they do seem to show smaller effect sizes, but they do seem to show beneficial effects of yoga.
Thank you. How would you recommend somebody encourage someone to become more mobile, say someone in their 80s?
That's a tough one. Because if they don't want to be out and they don't want to be physically active, it's hard to have motivation that's external, right? We need internal motivation for it to become a habit. But I would say try to capitalize on something that the person is interested in. So if they're really interested in, I don't know, I'm just going to pick something, knitting. I don't know. I like knitting. I'm terrible at it, but I like knitting. So I would want to go to a knitting store a lot to buy the materials. You go through that stuff pretty quickly, right? So if that's something, take that person somewhere where there's a store in a mall that has the materials and park a little bit further away than you normally would. So that encourages them. So kind of using something that they're interested in and capitalizing on that. I think that might be something. I have two young children, so I use them as much as possible for my benefit. So, if there's grandkids around, bring them over. So even playing with your grandchildren, we know there's been research to show that playing with your grandchildren, even if you're not running around after them, even just interacting with them is good for your brain in different ways.
Oh, that's great advice. Um, okay. If a higher number of pregnancies has impact on the brain functioning, is there evidence of cultural or societal differences linked to the size of family in the data that has been factored or not recorded?
That's a great question. This research is really in its infancy, I'd say. Like I saw a figure about like of all the biomedical research studies out there, only 0.04% think about pregnancy and even less think about address long-term effects of pregnancy. So in my own work, we haven't been able to look at cultural societal differences yet because we don't always gather that information, especially when we're looking using cohort data. Those are done by other places and we just get access to that data. So we don't get to ask all the questions I want to. In fact, for example, we even aside from like a culture and societal variables, which would be even harder to get a hold of, they don't even usually ask what type of pregnancy women have had, let alone if they've been was there hypertension in the gestational diabetes? Because we know those type of pregnancies are different than normative pregnancies. So we don't get all the variables that we would want to look at. So as far as I know, no one's looked at cultural differences quite yet. We did do one study when I was a postdoc at Simon Fraser University where we had data from Guatemala, and we looked at the number of pregnancies a woman had and then looked at a marker of cellular aging called telomere length. Those are the end parts of your DNA, and they get shorter the older you get. And we looked at whether the number of pregnancies could change the typical reduction in that length. And we actually found the opposite of what we thought. In Guatemala, the women that had more pregnancies, and they had pregnancies up to like 13 children, they actually had longer telomeres. So they seem to have slower cellular aging, which is the opposite of what we had predicted. So that's like the only type of thing that we've really looked at in terms of cultural differences. We just went to a different culture to look at our questions.
That's very interesting. Okay, if someone with early or middle stage dementia increases their exercise, could there be an improvement in cognitive function?
I would predict yes, I think so. So we did a meta-analysis. I was a part of it right before I left UBC, and we looked at exercise interventions that were done in people living with dementia, and it was at earlier stages and progressed dementia as well. And we found in that meta-analysis that exercise interventions did have a beneficial effect on cognitive function, executive functions, and on overall cognition and memory as well. So I would say absolutely, we would predict that they would be helpful.
Thank you. So if anyone else has any last minute questions, I welcome you to type them in the chat now.
Oh, do you want me to give my email address?
I did give it, but if
Okay.
you want to forward it. I know a couple people were wondering if we would be able to get your slides. So, and perfect, it is there up on the screen. So this presentation will be recorded and available to watch on our YouTube channel. So if anyone wants to hear it again, it will be made available. So we went a few minutes over, but that was so interesting. And I just thank you so much, Cindy, for presenting for us tonight. And if anyone has any follow-up questions, you can email Cindy or myself. Or of course, if you need some support about dementia and diagnosis, please give our helpline a call at 1-877-949-4141. And we will send out a follow-up survey and some resources following this presentation. So thank you.
Thank you so much.